Okay, video 3 on work energy power. So here's the problem. What size electric motor would be needed to lift a freight elevator that when fully loaded weighs 3,000 kilograms and it's going to be raised 20 meters in 2.5 minutes? So the first thing you want to do is you want to look at and say, well, what is the question asking us? The question asking is, well, what size electric motor? And, how do we measure motors? We measure motors in horsepower, right? So then we go, okay, well, what is the formula for horsepower? Well, the formula for horsepower is power in watts divided by 746. Okay, so that's fairly simple. And we go, well, do we know watts? Do we know watts? No, we don't know watts. And what is the formula for watts? Well, we know formula for watts would be E times I, but we don't know E or I, so we have to go, okay, well, what about the other power formula, which is work over time? We could say, well, okay, so power in watts is equal to work over time. And we go, okay, well, let's see, do we know time? Yeah, we know time. Time is 2.5 minutes. We know that. Do we know work? No, we don't know work. So we go, okay, what's the formula for work? In this particular thing, well, we have a force that we have to calculate. The formula for work is going to be force times distance. So work is equal to force times distance. And do we know the distance? Yep, 20 meters is the distance, but we don't know force. So what kind of force are we talking about? Well, if it's an object that's being lifted, we have to factor in gravity. So, okay, well, we go, okay, well, if we're factoring in gravity, then we say, well, the formula for force in newtons is going to be equal to my mass times my gravitational constant. We know what that is because it's being lifted, which is 9.807 meters per second squared. And we know our value in mass, which is 3,000. So we know these two, so we can actually start right here and go, okay, well, 3,000 kilos times 9.807. It's going to give me, well, it's going to give me a pretty big number. So I've got 29,421 newtons. And we know that work is equal to force times newton, so I can take that number and put it into there. So I say, okay, well, I know my force now. My force is 29,421 newtons times my distance, and we're saying my distance is 20 meters. So if I do that, 29,421 times 20 meters was going to tell me how many joules. So I've got 588,420 joules. Okay, easy enough. And we know that my power and work is power is equal to work over time. My work is 588,420. So I can just take this number, 588,420, and divide it by my time in seconds. So let's take a look. 588,420 divided by my time in seconds. Well, I'm saying 2.5 minutes here. 2.5 minutes. So I've got 2.5 minutes times how many seconds per minute. We got times 60. It's going to tell me how much power. Because power is work over time. It's going to say I've got 3,922.8 watts. And we know that my horsepower is going to be equal to my wattage divided by 746. So 339.22.8 divided by 746. 39.22.8 divided by 746 is 5.258 horsepower. So that would be your answer. Realistically, you're not going to get a 5.25 horsepower motor. You will a 5.5 horsepower motor, or perhaps a 6 horsepower motor, in order to factor in, a little bit of leeway there. Anyway, that's how you do that. Next video will be video 4, work energy power.